Alright guys, this is October 12th through the 16th. We're looking at lesson 11, so make sure you have that out with you. We're looking at unknown angle proofs, proofs of known facts. We have been talking about proofs. This is just a abnormal time, so therefore you've been introduced to proofs a little differently than what I would normally introduce them to you. So they're probably a little more difficult to do. But remember, a proof is simply just proving why something is the way it is. Alright, so let's go ahead and look at our opening exercise. This lesson has a lot of discussion to it, so we're going to be doing a lot of talking, a lot of thinking about things. So it says, a proof of a mathematical statement is a detailed explanation of how that statement follows logically from other statements already accepted as true. So if you think about what we've done, we go step by step by step in proving something. And we look from step to step. How does the step below relate to the step above it? And that's what we're looking at. We are truly just looking at why something is. A theorem, which you should have theorems in your notebook now. A theorem is a mathematical statement with proof. All right, with a proof. Theorems can be stated without reference to any specific labeled diagram. However, we cannot take steps to prove a statement without a way of referring to parts. All right, so we're gonna see that here in just a little bit. All right, so let's talk about using facts that are already provided in a list to prove a certain fact. All right, so we are at the discussion part. Once a theorem has been proved, it can be added to our list of known facts and used in proofs of other theorems. For example, in lesson 9, we proved that vertical angles are of equal measure. And we know from earlier grades and by paper cutting and folding that if a transversal intersects two parallel lines, alternate interior angles are of equal measure. How do these facts help us prove that corresponding angles are congruent? Well, if you remember, corresponding angles, and we'll use the figure here, corresponding angles, if I look at angle Y, corresponding angle would be angle Z, or angle X and angle W are corresponding angles. So how does knowing that alternate interior angles or vertical angles are equal in measure, how do these things help us prove corresponding angles are congruent? Well, if I know that Y and X are vertical angles, then I know that X and Z are alternate interior angles. Because I know that vertical angles are equal, I know that Y is equal to X, and so therefore then I know that X is equal to Z because of alternate interior angles. So then I can look at the relationship between Y and Z, and they are corresponding angles. So therefore now I've proven that they are congruent. In the diagram to the right, if you are given that segment AB is parallel to segment CD, how can you use your knowledge of the congruence of vertical angles and alternate interior angles to prove that X is equal to W? So it goes right along with what we were just talking about. First of all, let's talk about vertical angles. Well, I'm looking at proving that X and W are equal. So what do I know? I know that W is equal to Z, Why do I know that W is equal to Z? Because they are vertical angles. All right, vertical angles are congruent. All right, so now I've proven that W is congruent to Z. So now that I've proven W and Z are equal, what do I know about X and W? I know that, I'm sorry, I've missed a step. Now that I've proven W and Z are equal, what do I know about X and Z? X is equal to Z because of alternate interior angles. And alternate interior angles are congruent. All right? So now, if I know that W is equal to Z and X is equal to Z, transitive property tells me that X is equal to W. And I can say that is by substitution. Or if you want to look at it as transitive property. All right? You now have available the following facts. Vertical angles are equal in measure, alternate interior angles are equal in measure, and corresponding angles are equal in measure. Use any of all of these facts to prove that interior angles on the same side of the transversal are supplementary. Add any necessary labels to the diagram below, and then write out a proof, including given facts and a statement of what needs to be proved. All right, so we've got to turn our page here for this. So we're given that segment AB is parallel to segment CD, and that EF is the transversal. So it wants us to prove that the measure of angle BGH, so this angle right here, and measure of angle DHG, this angle right here, equals 180 degrees. Alright, so the very first thing I can do is I need to write my given statement. My given statement is that segment AB is parallel to segment CD. And the reason is given, because that is given information. I don't have to prove it in any way or anything like that. It is strictly given information. Alright, so because it's given information, we already know vertical angles are congruent, alternate interior angles are congruent, and corresponding angles are equal in measure. So, let's think about this. I want to prove something here about them being supplementary angles. Well, let's think about this for just a second. What do I know about these two angles here? AGH and BGH. They are supplementary angles too. So the measure of angle BGH plus the measure of angle AGH equals 180 degrees. Why do I know that? Because they are linear pairs, and linear pairs are supplementary angles. Alright, so if I know those two angles are equal to 180 degrees. Alright, now, so let's think about this. I have used this angle. Now I'm going to somehow use this angle. Well, what do I know? What do I know about the angle the angle GHD. They are alternate interior angles. So I know that the measure of angle AGH is equal to the measure of angle GHD because alternate interior angles are congruent. Alright? And normally we would write out a big long statement. If two parallel lines are cut by a transversal, then alternate interior angles are equal in measure. So now let's look at this. My statement is the angle BGH plus the measure of angle DHG. Well, what do I know about the measure of DHG? It's equal to the measure of AGH, so I can now substitute. So the measure of angle BGH plus the measure of angle DHG is equal to 180 degrees because of substitution. Alright? Because I have proven that the angle AGH and the angle DHG or GHD are equal, I can now substitute. Okay? Now that you have proven this, you may add this theorem to your available facts. Interior angles on the same side of a transversal that intersect parallel lines sum to 180 degrees. So we now have a new theorem. We now know that same side interior angles equal 180 degrees. Use any of these four facts to prove that the three angles of a triangle sum to 180 degrees. For this proof, you will need to draw an auxiliary line parallel to one of the triangle sides and passing through the vertex opposite that side. Add any necessary labels and write out your proof. Alright, so we're going to draw an auxiliary line, and it says I'm going to need to draw an auxiliary line parallel to one of the triangle sides, passing through a vertex. I'm going to draw my auxiliary line here. And no, mine is not going to look perfectly parallel, but that's okay. I'm going to create my auxiliary line here. And I'm going to label my angles. So I'm going to label this A degrees, B degrees, C degrees, and then we'll do D degree here and E degree here. Alright? Alright, so my first statement in my proof is going to be that I draw auxiliary line, and we'll name this JK. So draw auxiliary line JK so that JK is parallel to BC. Alright, so that is my first thing that I'm going to do. I need to put that I am going to draw that. Alright, so we have just been given a couple different things that we can use here. But I want to prove that the three angles equal 180 degrees. Very first thing, angle A is an angle inside my triangle. So what do I know about angle A? Well, look at everything around it. I know that D plus A plus E is equal to 180 degrees. Why do I know those three angles are equal to 180 degrees? Because angles on a line sum to 180 degrees. Alright, so I know that these three angles here are equal to 180 degrees. So now, because we've drawn parallel lines, guys, this is a transversal. Alright, and I can look at this as a transversal. So now, let's think about this. Let's look at this as a transversal. Because this is a transversal, what do I know about angle D and angle B? I know they are alternate interior angles, so therefore they are equal. So D is equal to B. Alright, alternate interior angles. Now let's flip over here and look at this as a transversal. And what do I know? I know that angle E and angle C are equal because they are also alternate interior angles. So now let's look at this. I know that D is equal to B. That's an angle inside my triangle. And I know that E is equal to C. That's an angle inside my triangle. So I can substitute now and say A plus B plus C is equal to 180 degrees because of substitution. Okay? Because I am able to prove that these angles are equal, I can substitute. If I know they're the same, I can substitute. Let's review the theorems that we have now proven. Vertical angles are equal in measure. A transversal intersects a pair of lines. The pair of lines is parallel if and only if alternate interior angles are equal in measure, corresponding angles are equal in measure. Interior angles on the same side of the transversal add to 180 degrees. The sum of the degree measures of the angles of a triangle is 180 degrees. Alright, so let's take a little side trip here. Take a moment to take a look at one of those really famous Greek guys we hear so much about in geometry. Over 2,000 years ago, he used the geometry we have just been working with to find the diameter of Earth. He did not have cell towers, satellites, or any other advanced instruments available to scientists today. The only things that he used were his eyes, his feet, and perhaps the ancient Greek equivalent to a protractor. Alright? So there's a video, and I'm not going to take time to show this. I will put it in the Google Classroom. And for those of you that have flash drives, I will make sure that it is on your flash drive. But take a few minutes and watch this. Alright, let's look at example number 1. Construct a proof designed to demonstrate the following. If two lines are perpendicular to the same line, they are parallel to each other. So draw and label a diagram, and then state the given facts and a conjecture to be proved, and then write out a clear statement of your reasoning to justify each step. Alright, so if two lines are perpendicular to the same line, so to be perpendicular, they would form right angles. Alright, once again, mine's not perfect. But it says if two lines are perpendicular to the same line, then they are parallel to each other. So here's what I'm given. Let's label our lines here. Alright, so I am given that these two lines are perpendicular to the same line. So segment AB is perpendicular to segment EF, and segment CD is perpendicular to segment EF. Alright, that's what I'm given. It says if they are perpendicular to the same line, then they are parallel to each other. So here's what I want to prove. I want to prove that segment AB is parallel to segment CD. Alright, well, so what do I know? I'm going to give this little intersection here, G, and this little intersection, H. So what do I know? Well, we just said that if they're perpendicular lines, then they are going to form what kind of angle? They're going to form a right angle. So I know that angle AGH and the angle CHF are both equal to 90 degrees. So I know that they're equal to 90 degrees. How do I know that? Because perpendicular lines form 90-degree angles. Alright? So now, look at this. The angle AGH is going to be equal to the angle CHF. Why? Well, since they're both 90 degrees, I can say that they are equal. And that is a property of the transitive property. Okay? Since they're both 90 degrees, I'm going to say they're equal. They both have the same measurement. Now look, since they're both 90 degrees and since they're both equal, they are what kind of angles? They are corresponding angles. So because I have corresponding angles, I can prove that AB is parallel to CD. If two lines are cut by a transversal, such that a pair of corresponding angles are equal in measure, then the lines are parallel. Okay? So I've proven corresponding angles are parallel. Alright, each of the three parallel line theorems have a converse or reversing theorem as follows. I want you to take time, read through those. Guys, converse just means I'm switching them. Whatever was first is now last. And then I would like for you to attempt this as homework. Alright? Guys, don't get frustrated. Take your time. I promise you this one's really simple. There's only 2 steps to this. You have 2 steps. So take some time, see if you can complete this proof.